Hi everybody, here's a look at my power supply that I built back in 1999 in the summer, shortly after I graduated high school. I made this thing and I've used it for all sorts of stuff and it's really come in handy. You can see it's totally custom plywood construction all the way around. All the pieces are screwed together and I've got rubber feet here on the back and on the bottom, which are really nothing more than sections of power cord, and got a nice carrying handle, latches in the front, the top cover totally removable, and there you can see got the wires here. That's like the main output right there, and a variac power switch, voltmeter, 2 ammeters for measuring 3 amps and 300 milliamps, and there's the output. Got a polarity switch here, some other connections I can use. This is all output right here, just different forms. And then we got all these different switches here. This is the voltage selection switch, so we can select 300 volt DC, or I'm sorry, 30 volt DC full scale, or 200 volt DC, 24 volt AC, or 140 volt AC, and that's all that just goes straight to the variac, or it goes to the variac and then to a transformer for the low voltage. And then I can select AC or DC, and then on the DC side I can even choose if I want a full wave sinusoid, full wave rectified sinusoid coming out, or if I want to filter it with capacitors. And then I can select how much the current range that I want to measure on the ammeter. And opening it is very easy. All I have to do is just pop the lid like that, and there's all this cool stuff down here, but it's very, very old school. There's no regulation. The only semiconductors in here are just the 2 full wave bridge rectifiers. Everything else is all switches and transformer type stuff. So here's the schematic. There's the 120 volt input. We got a 3 amp fuse and a neon lamp indicator. Got the variac right here and the low voltage transformer. And then there's a 6-pole double throw switch right here that all selects the voltage range, either high voltage or low voltage. And then there's a better look at it, the full wave bridge rectifier. That's only for the ammeters actually. They're both DC ammeters, and in order for me to measure AC, I gotta put a full wave bridge rectifier on them. So that's why that one's there. And then the other full wave bridge rectifier is right here. That one is for the main power throughput. And then trying to get a good angle here. So there's I got a 10 kilo microfarad, 10,000 microfarad capacitor. Actually, I think apparently 14 years after making this thing, I have a correction to make on the schematic, because the capacitor is actually 4 individual caps in series. Each one is 10,000 microfarad. So that would be 2,500 microfarad total. And of course got a discharge resistor to bleed off resistance, the bleeder resistor when it's turned off. And this inductor, the series inductor on the output of the capacitor, is not really inside the box here. I figured that would be an addition for some time later, but never actually put it in. And what else we got here? I had to stop and pause there for a minute because apparently there's another inconsistency here. This resistor and capacitor looks like I was going to put that across the voltmeter only when it's in DC mode and also when it's in high voltage mode. And all other times it would not be in circuit, and I have no idea why I was going to put that there. So I'm just going to erase it. I mean, after all, I was just in high school. I just graduated high school. You know, I had experience with electrical stuff, but you know, I didn't even have a 100% grasp on Ohm's law at the time. I had physics courses with electromagnetics, you know, the basic resistor, capacitor networks and stuff, but nothing fancy. Anyway, got some more switches here. These are this pair. This is actually a single double pole, double throw switch for selecting the range, either 150 volts or 300 volts on the voltmeter. And then there's the main polarity output, so I can select positive or negative polarity going to the output terminals. And here's a close look at the inside. The power cord is actually mounted or stored inside this little storage chamber here with a spring-loaded door. And if I can dig it out, there it is. So I just plug that in and the cord sticks out. When I'm all done, I wrap it back up in a coil like this and stick it back in. It's a very, very convenient way to store the power cord. And then there's also storage for spare fuses, because this thing blows fuses a lot. I mean, I should probably use fuses that are rated for a little more than what I actually intend to get out of it, but that's what I did back then. Then there's the 4 capacitors, 50 volt each, 10,000 microfarad. I actually got these out of a really old entertainment system amplifier, audio amplifier thing. And there's also, I left space and a connection for that inductor that I never put in, but it's there if I ever need it. And there's the high voltage to 24 volt transformer, a couple of full wave bridge rectifiers mounted on a heatsink. And then moving up, got the variac right here. There's the bleeder resistor. This was kind of an afterthought. I didn't have this at first, but then I put it there sometime later. Oh yeah, there's the indicator lamp. Here's the voltmeter with the resistor dividers and got some pots on here so I can fine tune the scale for the 150 volt scale and the 300 volt scale. There's the selector switch for the scale. And there's the 2 ammeters, of course, switches, the rotary switches up here. And then there's all the output terminals. You can see they're all just wired. That one, that one, that one for negative, and these 3 for positive, and there's a ground right there, and the polarity output switch. And I got some extra wires here too. I put these in there. This is all included inside this multi-conductor cable right here. You can see there's the pink and brown and the yellow, pink and brown, white and black wires in case I need any extra connections, but after 14 years, never used it. Now the 120 volt power outlet, I actually made that so I can rotate it like this. And I put a steel wire or some kind of steel antenna that I must have got off of an RC car or something, and I tied it to the wire right here just to keep it rigid, and it coils up nicely. You can see it turning like this. And I did that just in case I ever plug in some big monstrosity like a wall wart, really old wall wart or something with the plug mounted right on it. Then I could, then I could rotate it away from the switch and all the terminals down here if I really needed to. As for the variac, you can see it's a nice 3 amp power stat from Superior Electric Company, and unfortunately during the design and construction process I really messed up with it, and I put a full 120 volts between the end of the wire here and the tap. I put the full 120 right there, and so as I cranked it down like this, there was ever increasing voltage on a ever decreasing amount of wire, so that really fried all the copper windings right here. So I had to get some extra, had to buy some 24 gauge wire and redo all the windings on here. It's a shame I caused such damage to this thing, because I got this from my grandfather. He had used this for his model railroad many years ago when I was a kid, and I loved playing with the model railroad and controlling the trains with this thing. And I also got all these switches he had on his model railroad thing, and even the whole concept of putting this control panel on a hinge like this, and so it's easy to open up and service the underside. That was compliments of my grandfather. Now the fuses, you can see I've used the little tiny 5mm by 20mm fuses, but I put them into the 1¼ sockets, and I did that. These were already mounted on a circuit board, and you know these individual terminals were spaced a little further apart. In order to shrink it, all I did was I cut a little strip out of the middle and then glued them together. You can see all the super glue residue that's left over here, and for some added rigidity I put some copper foil on the top and the bottom just to hold everything together. And one final detail to point out is this thing right here. In order to make I'm not using all of them, but I could potentially use this as an 8-pole double throw switch. And you can see I have 2 identical rotary switches. Each one is 4-pole, ganged together, and I just mounted this one on top of the other with some thick copper wire soldered directly onto the steel casing. And down here there was already a hole in the circuit board, and I must have taken this one apart, must have taken off the circuit board here and opened it up, and then soldered this copper wire onto the shaft of the first one, and then again soldered it onto the second shaft. And it works beautifully. It has never failed me yet. Okay, now it's time to see this thing in action. First of all, let me point out that the voltmeter right here is a Weston DC voltmeter with a full scale of 30 volts, and it shows 30 volts when I have it in low voltage mode. Let me switch it on here. Switch on the load too. And you can see it goes up. It's reading exactly what it says. Well, almost exactly. You can see how here I have I'm in AC mode, and I got 20 volts showing here, but actually on the DMM we're looking at 23 volts, and that's just because on the voltmeter that's receiving a DC voltage off of the main power rectifier, even though I'm not actually using it to supply AC current to the load. I'm still using this for the voltmeter, so it's a little discrepancy, but it's in the ballpark, and for most applications that's really good enough. I don't need to make any precise measurements right here on the power. Now the load that I have here is actually, this is another reason why it's good to have the rotating plug, so I can put these light bulbs on here and they won't get in the way. And this is a couple of black lights, 75 watt black light bulbs, and then there's 100 watt carbon filament lamp. And let me turn that on, put it on 140 volt scale, and crank it up, and you can see the current here. We're going to get to about 2 amps. And again, the current is not very accurate too. It'll be plus minus 100, 200 milliamps or so, but just because of the rectifier situation, and I'm actually trying to measure AC current on a DC meter. But again, it's close enough. And I got 135 volts on the DMM, whereas this one is only showing about 120. And again, this is the 150 volt scale when I'm in this the high voltage mode. So we're looking at 25, 50, 75, 100, 125, and 150 volts. Another thing to notice is that if I switch off the load, then you can see the voltage goes up a little bit. It drops down a little bit, and then it goes up a little bit. That's just from all the parasitic resistance and all the wires on the inside. I should have used some thicker gauge wire when I made this thing, but heck, I didn't know any better. Now I'm going to put it in DC mode, and we'll leave it unfiltered. It would help if I switch on the load. I'll turn it all the way up again, and now we have much better correlation between the DMM and the Weston meter here. They're almost exact at 120 volts. And that's just because I'm actually powering the bulbs with the same DC source that I'm using that goes to the DC voltmeter. Now I'm going to put it on filtered DC, and we'll look at the 0.3 amp scale, and let me also switch off the load here, and then you can see as I turn up the dial, then the ammeter goes up a little bit. That's just because of the current that's needed to charge the capacitors. So it's very critical that I don't have this thing turned up all the way and then go over to filter. Otherwise I'm going to blow the 315 milliamp fuse that I have in series with this. So let me turn that down, then turn it off, and then the bottom position of the power switch is the discharge for the cap. That puts the 1 kilo ohm bleeder resistor in parallel with the capacitor. So I'm bleeding that down, and then turn it back on, and we'll go to the 3 amp scale. And this time I'll switch on the load. And there's 2, and you can see, whoa, and there it blew at not even 2.5 amps. I'm not sure. It's a 3 amp fuse. I don't know why it blows so quickly. So I got it popped open, and let's yank out the fuse here. Yeah, it's a blown fuse, all right. I better be careful. I don't have very many. I don't have too many more to spare. Anyway, the point I was trying to make is that if I disconnect the load here and then crank up all the way, you can see that I quickly reach 150 volts DC, and that's my reason for putting the 300 volt scale on the voltmeter. So now I can read up to 200 volts on the meter. Alright, we'll have one last look at this thing on the scope, and if I had it on the low voltage mode, I wouldn't need an isolation transformer, but in this case I do have it on an isolation transformer on the input of the device, of the power supply, so I can actually hook up the ground connection of the scope without blowing the GFI outlet. So let me zoom in on that. And I'll crank it up very slowly. I have it on the DC full wave rectified but non-filtered, and you can see it gets up to about 170 volts as expected. Let me turn that back down. This time we'll put the filter on, and again I have the load on here, and we'll see what kind of a ripple we get. And still pretty good. I'm drawing 2 amps. Let me put it on AC mode and zoom in here a little bit. So we're getting on the, using a 10x probe on 2 volts per division, so that's going to be what, plus minus 2 volts. So there you go. That's my universal power supply that I made some 14 years ago, and other than blowing fuses once in a while, it works very well. And of course, even though it's not regulated, for most things that I use it for, I don't need a regulated supply. I just need a dumb power supply to give something 120 volts or 12 volts or something like that. If I really needed something regulated, like a 5-volt supply, then I'll just put a 7805 into my circuit. So closing up is just as easy as putting the cover on here, closing the latches, and so if you like this power supply, then please give the video a big thumbs up. Thanks for watching.